Thank you.
MSc Forestry student at School of Forestry and Natural Resources Management. And it is my pleasure to welcome you all in the third and final day of our IRF International Conference. I hope you had a wonderful and enriching experience during the conference so far. Before we begin, I would kindly request everyone to please take your seats. As we are ready to start today's session. Now, without further delay, I would like to request Dr. Vishwanath Holi sir to hand over his stage. Dr. Vishwanath Holi is a distinguished Nepali forestry professional, former secretary of Government of Nepal, and a country representative of CIFOR, ICRA of Nepal. He has extensive experience in forest policy, biodiversity, climate change, and natural resource governance. He has served as junior member of IPPES since 2022, contributing to global biodiversity and ecosystem services, science policy processes. Thank you, and over to you, sir.
Good morning, everybody. Distinguished participants, ladies and gentlemen, and keynote speaker of this session, Dr. Dovan Rai, Director of Body and Data. So we will have 30 minutes of presentation from Dr. Dovan Rai. Then we will have opportunity to take few questions from the floor. Then we will wrap up this session within 1 hour. So without further ado, I would like to invite Dr. Dovan Rai to deliver her presentation on AI for forestry in Nepal, exploring the landscape of possibilities. So Dr. Rai, the floor is yours.
Good morning, everyone, and my heartfelt thanks to Institute of Forestry and the organizing team for giving me this opportunity. So today I'm going to talk about AI for forestry in Nepal, exploring the landscape of possibilities. And as a disclaimer, I want to mention that I'm not a forestry expert. I have done my PhD in using AI in education. So here today I'm just trying to again also an exploration for myself. I'm trying to map just the possibilities. Okay, let me start my presentation. So this is a brief outline. First, I'm going to talk briefly about AI and algorithms, how the algorithms work, AI techniques and capabilities, and how they can map to different forestry applications, bottlenecks and constraints, which we in Nepal we have to be very mindful about, risk and ethical concerns, and finding responsible AI. So let me first talk, because now here, we hear a lot about AI and algorithms. Even now, we have like really powerful algorithms, but algorithm as a word itself is a very big fundamental concept. So in computer science, we describe algorithms as a set of instructions for solving a computational problem. Whenever there is a problem and we can frame it as a computational problem, and the way we solve it, we call it an algorithm. So it can be a very simple algorithm. For example, if you have a list of numbers and you want to order them ascending or descending, it would be something like our Google Maps, right? Mapping algorithm. So based on the start, location, and destination, it is going to give you your travel route. Or it is going to be something like our recommendation algorithms, where based on the user data, different those platforms are going to recommend you or content. So also in forestry can use different kind of algorithm. So it could be a very simple algorithm, it could be very advanced, it could be big, it could be small, right? But then, yeah, we can use different kind of computational techniques to solve our problems in forestry. So let me talk about what is AI and how the AI algorithms work. So I think for I don't know the audience, I think a lot of you are already working in different computational methodologies and we might be very well aware of different AI techniques. But for a lot of people, the word AI was, very, so they got to know about the AI since 2022 after the ChatGPT launched. But the history of AI is quite long, and like the word was more like 1956, almost 70 years ago. And this really has gone through a lot of ups and downs. There has been some very like optimism, and there was this AI winter, and right now we are in this another very big optimistic era of AI. But we are going to see how things are going to unfold. So again, the AI, the very basic definition is like AI is a system that can solve problems autonomously with human intelligence. And also, I want to mention that AI is a very broad area. There are a lot of different techniques. Some are very logic based, and some are data based. So machine learning is a subset of AI that uses data to make the intelligent system. But AI as itself is a very broad field, So there are like symbolic AI, rule-based AI, which don't necessarily rely on the data. So but now like machine learning as a technique has become very powerful. So machine learning and AI has been almost synonymous. But I also can emphasize that AI is a very broad field. And again, generative AI is a subset of machine learning, and ChatGPT is one of the very popular app within the generative AI technology. So here we have been using different generative AI, and even with our Google, right, search, classic spam, we have been using AI. Similarly with our personalized recommendation, Facebook, YouTube, or TikTok, and also the image recognition. And there's a lot of facial recognition software that uses AI, image detection techniques, in medical imaging. AI is used to read the X-rays and those medical images, and also like autonomous driving. And I also want to mention that because there's a lot of very similar topics, right? AI, machine learning, statistics, data science, big data, data analytics, business intelligence. There are so many, words in the field. So data science or statistics or data analytics, they have this very, AI and data science overlap them a lot. So there are a lot of techniques which are kind of, you can call them data science or data analytics, and they also are AI techniques. So I want to show a very, because we only have 30 minutes, so I'll try to give a very small toy example of how machine learning algorithms work. So let's imagine, right? I think we have been using this image detection, facial detection app. So let's try to see this very small toy example that we want to create an image detector that is going to look at an image and detect whether this image belongs to a rhinoceros or not. So for example, if you saw this picture, it is going to say that this is not a rhino. But if you saw this picture, it is going to say that this is, yes, this is a rhino. And if you saw this picture, it is going to say that it is not a rhino. So it's a very traditional programming, right? That is not machine learning when you have to build something, a detector. What we do is that we create this if as logical statement, right? We first try to describe how a rhino looks like. This body, its color, ears, eyes, and like that. But then for some problems, this kind of traditional programming works, right? But in some problems, those programs are not going to work, right? Because how are you going to define rhino, in the image, right? Because this kind of traditional programming is not going to suffice. So in some cases, we use machine learning. So what we do is we start trying to very extensively or define how a rhino looks like and what is not a rhino. What we do in machine learning, we just show them the data, right? We just show them the pictures of rhino and the pictures of that is not rhino. For example, those all are pictures of rhino. So what we do, we give the machine learning algorithm this picture of rhino, different pictures of rhino, and then we tell them this is rhino. because we know that the machine doesn't know what a rhino looks like, right? And we also give them different pictures that are not rhino, and we also tell them this is not rhino. You know, the way we teach young children or like our pets, right? Okay, this you can eat, this you can eat, here you can go, you can't go. So like these little children and our little pets, we kind of teach machine learning algorithms like this, right? Just giving them examples. So then what happens is, like, once this machine is given a lot of pictures, like rhino or not, then the machine learning algorithm is going to see the statistical patterns in the images, right? It's going to see the pattern, and then it is going to build a model. It is going to deduce, the common features of what a rhino looks like. And based on that statistical pattern, it is going to create a model, which is called the rhino detection model. And then once the model is created, we can use that model to use, right? Once this model is created, we can show the new picture and ask them whether this is rhino or not. So this is kind of like in the machine learning. This is there's a two major state. One is called the training phase, and another is called the inference or prediction phase. In the training phase, what we do is that we feed them a lot of model, a lot of training data, and based on that training data, it is going to create a model, right? The model, AI model, is basically a statistical model, right? It is going to find the patterns. And once that model is created, then we can use this model to answer new questions, which is called the inference or prediction phase. And here, like for all the image detection, so you are going to feed hundreds and thousands, and sometimes even millions of training data to detect those images. So this is one example of image detection, but the fundamental concept is very similar. For example, now you can use ChatGPT or Claude or DeepSeek models, right? And there you can ask the ChatGPT model to, let's say, write an essay of a rhino, or write a poem of a rhino, or say that, oh, write a really nationalistic poem of a rhino. So what the generative AI or the DeepSeek or ChatGPT or Claude model does is they kind of they feed onto a lot of whatever is there on the internet, right? The documentaries, the essays about rhino, the specification of rhino. They look at the documentaries, whatever is possible, and they have looked at different poems, Nepal's nationalism, and based on that, when it looks at different domains, gives a lot of data, then it is going to create its own model, right? Its own statistical pattern. What a rhino looks like, what Nepal's nationalism looks like, what a poem looks like, right? And based on that pattern, when you ask the generative AI to, let's say, write a very nationalistic poem on rhino, it is going to combine these different patterns and give you your answer. So, as of that, we use machine learning. Of course, there's a lot of different techniques, a lot of advanced methodology, but the fundamental concept is the same, right? So, the machine learning is going to look at a lot of data, find the statistical patterns, aggregate all the numbers, the statistical patterns, and create a model or a heuristic. And I think another fundamental question we need to ask is how intelligent AI is itself, right? Because we say AI, artificial intelligence. How intelligent is it? So because most of the tools that we use, the big tech tools like the ChatGPT or even Facebook, they sound pretty intelligent. But then let's look at this example, right? For example, if your training data is only derived from the textbook images, right? Like those kind of, very standard images where the rhino is only shown from this one direction. If you train your AI only from those images, but in the prediction phase, in the inference phase, if you ask this AI whether it's rhino, it will probably say no, right? Because for this model, rhino must have this, this kind of body and legs, so it's not going to identify this as rhino. And let's think about another scenario where you train this model with, let's say, very scenic images from National Geographic, where the rhino is in some kind of outskirt, and there's a lot of birds around his nose and horn and back. But if you train, use only these images. Again, if you give that image something like that, the AI model might not detect this as a rhino, right? Because it doesn't really know what a rhino is like the humans do. Because he had only seen images like rhino with the birds and the back. So as long as when it doesn't find this bird, he's going to say that this is not a rhino. Whereas So this is just to example, right? And this is very common mistake that AI does. So what the AI can do is, right, because if it's going to just look at a bunch of bird, it might look at the pattern of the bird, the cluster, and it might endlessly think that the cluster of birds is actually rhino. So when it looks at an image like this, it might say that this is a rhino. So what I'm trying to emphasize is that your AI model is maybe as intelligent as the data, right? If you give them very diverse, very robust data, it is going to be more intelligent. But if you give them very biased, very limited data, it is not going to be very intelligent. I think I don't know how many of you are old enough to know the Facebook face detection system, right? When that face detector was launched, it was not very intelligent, right? It would, like, in my case, like, it would sometimes tag my cousins as myself or tag my images as my cousins. But later on, because when it saw a lot of my images, it got so smart that, it didn't even need to see my whole face, right? Even, a blurry or fuzzy, it would be able to detect me. So the thing is, this AI system, these machine learning systems are heavily depend on the quality and the breadth and robustness of data, and its outcome of power is also dependent on that. So that's why this algorithm device is a very important concept in machine learning. So what it means is that machine learning algorithms learn from the data, and if your data is already erroneous or biased and limited, your model is going to, detect that bias, that error. And again, this is one example in New Zealand. So they created this like AI robot, right? That is going to take your pictures and tell you whether the picture is good or not, like the background, your face, So because in New Zealand, because it was trained on this Caucasian faces, right? More European decent faces. So what it did then when this AI robot trained on the Caucasian faces, it took a picture of an Asian decent man. Everyone was told that he's closing his eyes, right? He has not opened his eyes. And because the faces that trained was very different than the faces it came to work on. And it might, it might not like very, I don't know, like embarrassing but a funny example. But then when the AI is used in very high stake applications, it can have very high risk as well. So this is the image generator tool, and this is the average image of what it generates. And when it asks the image generator tool that I think the tool they used here was the open source one, Stable Diffusion, something like OpenAI. So what it did is like ask the generator the image of, let's say, CEO or Jaws, it will show you more white face, right? But when you ask them, right, like show me the picture of the dishwasher or housekeeper, it will show you more brown faces. And when you ask it to generate, like, oh, show me the picture of inmate or drug dealer or terrorist, you get to see how our social bias, the prejudice, it is kind of reflected directly on your face, right? So here the bias can not only be reflected, but it can also amplify. Because now, because a lot of this big tech software, because they used to make a lot of those errors in the past. So there's a lot of losses. So now they're careful to kind of control, like intervene human and control this. But this is what our data ecosystem, and this is how what are we saying is that whatever the bias is in the system, that the AI is going to not only amplify, even there's a positive feedback loop, and so I have tried to go for it, but I think you got my message, right? So and here in the algorithm bias, there's a minor effect, right? As you saw, if you have a very diverse data, those bias can be minimized. But if you have very few data, this bias is going to be amplified. So the AI is going to be more error prone. And you can even see when you use ChatGPT, right? The level of correctness in Finnish language versus Hindi versus Nepal, you can see how the error rate increases. So here, when you go to the new domain like forestry, Nepal, right? So when you are using AI in new domain, you have to be very careful. Also for the marginalized community and for the developing world. So what am I saying is that I think as Nepali people, when you use these AI tools, you have to be very mindful, because And other two the concerns are because AI is a probability system, right? It's not a deterministic one. So what it does, like it works with probabilities, so there's always this, the margin of error. We also call it hallucination, right? It's not that you don't hallucinate, it's always the AI systems are always, working on the probability. So there's always this margin of error that we have to be very careful about. And also there's a black box problem because all these big complex AI systems, where you can get the result, but because those are very complex systems, you can't, they are not explainable. So you sometimes you are not able to, the AI is not able to explain, its conclusions. And that's also very important when you are making these very high stake decisions. So there's a lot of machine learning techniques, right? And we can also see from the classes intelligence, right? There's different ways of looking at the intelligence. So let me show this slide, like AI capabilities, right? The basic AI capabilities, like the image recognition that I used to show you this example. There's sound recognition, there's prediction, recommendations, and generation. And I was trying to map into different forestry applications. For example, you can use the AI image recognition capability to identify tree species, disease trees, forest types. You can use the sound recognition AI capability to detect chainsaws, wildlife calls. You can use the prediction capability to predict wildfire risk, pest infestations. Similarly, you can use the AI recognition capability to help forest managers prioritize area for protection, restoration, or monitoring. And also you can use the AI generative capability to generate forest growth information, right? They'll just give them the data and they just, tell the AI to generate the simulations or report. You can do a lot. So now I kind of try to map the major forestry applications with AI techniques. So one of the widely used applications is for forest monitoring. So you use geospatial mapping to create this very detailed, very robust forest maps. And you can use again wildfire detection. And risk prediction is another major application area. Here you can use a lot of sensor data, sensor analytics like soil, moisture, temperature, rain, weather and satellite data to detect the fire early, predict spread fire, and even attack high risk zones. Similarly, another area is wildlife and biodiversity monitoring. Here you can use this image and sound recognition capabilities. Similarly, things like illegal logging and encroachment detection. Here also you can just see animal detection, right? Because whenever you see you have these detectors, and when you see this animal detection, you can just flag flag for that. And similarly, forest restoration or carbon monitoring as well. So you can use a lot of time series analysis. You can take data snapshot and try to see the pattern. Again, I'm not a forest expert, right? So I think it has a lot of other applications that you can map into these different AI capabilities. And I'm showing some like case studies, right? So one is the global forest, or if you use the global forest was now what's called global nature watch. So this is again one very major endeavor where what they are doing is like for the forest monitoring. So despite just using satellite static images, but if they use this complex AI models, what they can do is like they can just look at the images and try to look at the more nuanced patterns, right? And you can use this nuanced pattern to get some insight about the deforestation and other kind of concerns. So what it's doing is that satellites are already collecting images, right? That is just not necessarily AI. Satellite is collecting a lot of images. So once you can access, I think this is the open source project. I think it also used by here in Nepal as well. I'm not able to dive deep into it. But then, so you can get both like a wealth data, and you can use this AI algorithm and create these models. And you can, once you have that, you can just onboard a lot of patterns. And that is going to give you like very deep insight to, and also and from that you can also gather some predictions and recommendations. And this is another example, rainforest connection. So here what they are trying to do is this illegal log detection. So they have kind of installed these different acoustic devices, and from the pattern of this the sound, so you are able to kind of detect whether there's an animal, if there's some chainsaws, some logging trucks going on. I think the rainforests are very high tones about this illegal logging, and they are using AI techniques to monitor that. And okay, this is another example. This is like they call it citizen science, and there's a lot of simple app that we use from the smartphone to kind of detect those different wildlife, plants, and animals. And there's also a mechanism that can also contribute, your knowledge. So there's a lot of those citizen kind of community initiatives as well. Okay, so I'm also very new to this thing. I've been learning about this only last week. So my job here is just to map the AI application in forest application in AI. So I don't claim that I have built any of those or wrote any of those. Okay, so now here, this is only one snapshot, right? Because again, you are the domain expert, you know your needs, so you have the data, and I think you can kind of plan and brainstorm and try to innovate different applications of AI in your particular context. Let me also mention the bottlenecks and constraints, right? So there's data, technical models, limitations, infrastructure, connectivity. So let me talk about data. So one of the major, as I said, right, when we use machine learning AI techniques, data is the major source of strength, source of error, and source of limitation. So I think here in context of Nepal, getting this like a very the data could be a bottleneck because a lot of data that is maybe available open source. I think they are mostly, again, I don't know, I'm just assuming, they are mostly from the global north, right? And certain kind of forests in the global north, which might not really generalize in our context. That's one limitation, having limited or biased data. And another is like, there are some open source, but then a lot of high resolution data is very expensive, right? And when we are talking about forestry, I imagine we need a lot of data from different sources, right? Sensors, satellite, and even different sensors. So that will be even the process of gathering this data, putting up the sensor, collecting, that will be very expensive. And the other is like I mentioned, that even you have all the data, because the AI models are always, you cannot, this is part of the system of the AI models, probabilistic error, black box problem, like lack of transparency and bias, right? No matter how much data. So those things are very intrinsic inherent in the AI modeling technique. So we have to be really careful and mindful about that. And when we are using, we need to be mindful about that, so that when we are making recommendation, when we are making some intervention, you have to be aware of the baseline limitations. Otherwise, it is possible that we make these very drastic interventions without considering the limitations. And again, I think the other three bottlenecks and constraints, I think it's obvious to me. I'm going to the next slide because I'm constrained of time. Now let me talk about different concerns as well. I think this is very curious and something like in forestry, because we know that because again, how our forests, how places they are, and how endangered they are, and whenever you use any intervention in forestry, we have to be very aware of the risk and ethical concerns. One is surveillance, right? The AI forest monitoring surveillance technique can easily be misused to monitor the community itself, right? There's a lot of ongoing conflict in the local and indigenous community and the government and the corporations and the big networks. So we have to be very careful that those surveillance systems might not be used against the local communities. And the other fact is data ownership and consent, right? When you go to the forest and you get the data, because that data is going to be captured and collected by this tech ecosystem. And once this data and knowledge is collected, so I think the data ownership is one of the major issues that we have to be careful. And a lot of times, the satellites or those drones and sensors are just going to collect the data, and that is going to make that's what local communities, right? And they are going to be exposed and vulnerable. And there are lots of cases where local communities, their secondary areas have been kind of exposed and enclosed. So I think that's also one big area of concern. And also optimize and discipline, right? As I said, these AI systems are very mechanistic systems. And it is what we are trying to optimize. For example, if you just want to optimize, maximize yield, it is going to give you different kind of recommendation, right? So when you are using these big powerful systems, what we are optimizing, what is the output, what are the trade-offs, who is going to decide that? That is also a big area of concern. And similarly, epistemic injustice. What we are trying to say here is because there is not a lot of local, right? The knowledge that has been passed through the generation that people have learned, and then this big technology, this big AI system, the tech ecosystem runs, and then so which knowledge are you going to give more priority? Okay, that's another one area of concern, and also the dependence, right? If you use let's say for our forest monitoring, if you use this very advanced tools from high resource companies or countries, you are going to be dependent on that. So we also need to care about the dependency. And finally, and how many of you have? I think now it's very big news. This big AI systems, especially the large language model AI systems, they are very resource intensive. Right? The data centers are very resource intensive. So I think sometimes when you say that, oh, let's use this very big AI systems for conservation of forests, sometimes it could be a very counter effect. Those very AI systems are going to be very positive for the environment. Okay, so this is I'm almost out of time. So having said that, I'm not trying to alarm, but I'm trying to say that those systems are very useful and powerful, but they are also risky. So I think here we have to make a decision, and I think the main thing is the decisions to be made by the domain experts, not tech experts, right? Just because you might not know the tech details doesn't mean that they are the one who can, make the decision. So I think whenever there is a tech application, no matter how powerful, how advanced, or how complex they are, the decisions will be made by the domain experts and the local community. I think that's my belief. And that's my final slide. And I think, I'm someone who did my PhD in AI, right? So I believe on the AI compatibility. Now the way AI is evolving, now the way is being owned and governed. There's a lot of things we need to be very careful about. So there are some kind of responsible AI principles, like by the CNC, data sovereignty and local ownership, transparency and accountability and sustainable humanity. I think we need to base our AI imagination or AI intervention, making those responsible AI principles as the fundamentals. And so that's my I think that's just the time. So thank you.
Okay, and thank you, Dr. Dovan Rai, for taking us through the concept of AI, its application in forestry, then bottlenecks and concept, and also the risk and ethical issues during application of AI in the forestry sector. So let's give a big hand to Dr. Dovan. I forgot to introduce Dr. Dovan Rai. So I apologize for that. Actually, he holds a PhD in computer science from Worcester Polytechnic Institute from the USA, and degrees in Electronics Engineering and Sociology from Nepal. Our research focuses on AI-enabled education, game-based learning, and technology for inclusive and accessible education. She has developed educational technologies, supported engagement, and promoted diversity and inclusion technology for a just and sustainable future. So now the floor is open for our discussion. It's basically based on Dr. Rai's presentation. If we have any queries, comments, or suggestions, so that are highly welcome. I open the floor. Please, while putting your concerns or questions before, please introduce yourself with name and affiliated organization if you have. So I saw one hand here, then here. So down here.
Thank you, Dr. Rai, for your wonderful presentation. It was really a good learning experience and something for everyone also. I don't have questions, just I want to ask your view. I use Dovan, currently working as a researcher at Forestry, Nepal. As we saw in your slide, the big subsets of artificial intelligence, machine learning is a small part of it, and large language models like ChatGPT, even a smaller part. However, AI talking as a whole is a bigger picture than just ChatGPT and Claude that we mostly use in our daily lives. Although some researchers recently have used machine learning in forest fire and GIS-based researches, I want to ask your opinion on what do you think would make us able to utilize a bigger picture of AI to make a ground level impact, a leap from chatbots to tailoring AI structure to our needs. Like you showed in one of the slides, the sound recognition system used in forest crimes and something like that. That has been used in Brazil, from 2022. Similar things in Nepal. It's like we are eating the food that is already now in there. But what would it take for a developing country like Nepal to do that? Given the limited economic resources that we have for investing in the artificial intelligence. Thank you.
Okay.
Thank you, madam. Nice presentation. My question is, now these days, everyone is using this AI. Teachers, students, even sports, science, they are also trying to use this other things. My question is, okay, we cannot stop using these things disciplinary. And so a lot of people are depending on that. It's giving a lot of information. That's fine. When do we see that this is creating a problem in our thought process, our innovation, children's thinking process? Even they are not doing any thought, any thinking, any creativity, and they are trying to find out the answer easily from the AI. So do you think that where is the line we can cut? How we can try to give a message to our student? How much they can use and where they can keep their creativity and innovation together while going through the study process? Thank you.
I'm Day3, professor at the Institute of Forestry. I do agree that the students, professors, everyone are using AI, but in the past, where how to draw the ethical boundary of the use of AI by the PhD students and the master's students while generating the text and writing thesis and articles. That we are facing challenging now. In the past, we used to test the algorithm like some software like turning authenticate that was used in order to identify the similarity index. But now the students, most of them, they have been using AI in generating the text, and then they have been claiming sometimes that they have been generated by themselves, and even the professors are also using AI. So we have been feeling what should be the ethical boundary and how should we acknowledge whether or not the text and other ideas are generated by AI or not. So you have to love some sort of guidelines or some critical boundaries in the use of AI in academic field. What is your thought in this context?
Yes, sir.
My question is, given Nepal's diverse forest ecosystem, limited ground data, and varying technical capacity across local governments, what must realistic pathway for integrating AI into Nepal's forest management, and how can we ensure that AI contributes rather than replacing the knowledge and decision making of local forest managers and government?
I don't see any hands raised, so we take first round of questions, 4 queries that we received from the floor. And then I request Dr. Rai to respond to this question.
Okay, thank you for these really great questions. So let me first answer using AI in forestry, especially in context of Nepal, what is the most reasonable or practical way to go ahead. Here, I think AI, so one is like the very high resource AI application, and one is a very low resource or low cost AI application, right? And I think Nepal can use both. And I think because, I don't know the forestry knowledge ecosystem here, because the forest of Nepal is not only the forest of Nepal, it's the forest of the world, right? So I think that there's a lot of international communities, academia, who are kind of this kind of, I'm there's this kind of global collaboration on that. So a lot of individuals, even there are completely compatibility from the global community. I think can find ways, avenues, because a lot of university, think tanks, research institutes, you can use those resources, right, to kind of use them. Again, have not really dealt too much, so it's my speculation. So I think it also can be big, but then here we have to be very careful when we say the high resources. Is it the open source, selective community, or those are more profit-oriented corporations? I think we need to make a distinction, right? So I think we need to have a global collaboration towards that direction. And even low cost, one example I showed you is like a smartphone app. And even now, even if you can't develop this AI system to make forestry intervention, there's a lot of possibility of using AI system for our education itself, right? For modeling, for simulation, for sandboxing. Because my AI education, so I naturally go through that. You can use this AI, different kind of AI techniques to create educational materials, to learn, to create simulation, this interactive, immersive simulation. I think that is one of the low-hanging fruit, I think. So I'll say those 2 points now. And talk about the concrete problems. Again, this is something a problem like global warming, right? It's not the Nepal's problem now. All even advanced economies and the university, everybody is not only driven university, all the big universities are struggling with the same question. So it has been its own like very wicked problem. Here, I would like to say that I think there was a point where we were able to use AI to AI. Now it has gone past that, I think now increasingly it is becoming more and more difficult to use AI techniques to detect AI. So what we have to use is, again, this is my very personal opinion. We can go on dive on the technology. I think our interventions will be more on the ethical and moral. So you cannot convince the student that not to use AI because I have an AI education tool, because that is not going to catch up. And there's a lot of false cases where you have to be careful. So I think the intervention, the orientation should be more, as I said, on the bigger question, right? I think those moral, ethical, philosophical questions should be driving. And the other thing I want to say that now we see this kind of like bifurcation. Some people are using AI to support as an aid, and they are really becoming better thinkers. And some people are using AI not to support but to replace them with thinking. they are becoming, sadly less comprehensible. And sadly, in the context of Nepal, I think most of us are of the other category, because of our foundation, its system, and our whole ecosystem. I think that's why the impact of the negative impact of AI is going to be even more drastic for a country like Nepal. So from that, again, as I said, this is not a simple solution that one professor, one teacher is going to solve in the classroom. We need to have some kind of like, kind of reckoning and, intervention on a large scale. So again, to sum up that, I think what the moment of the world right now is we have to be very practical and very agile and very solution-oriented on individual basis. But then it's not an individual problem. So it's time that we really kind of like this concept, right? Kind of extend ourselves to the bigger community, so that we can think about the problem together and try to solve the problem together.
Thank you, Dr. Rai. So I request the participants, if you have any queries or comments in the second round. So, yeah.
Hi, I'm Ras associate with on campus. I have a very simple question. The question is, do you know any organization or any person, any professors, any experts who are working merging AI and machine learning in conservation, particularly wildlife conservation? If yes, would you like to share some? Thanks.
Yeah.
Thank you, Dr. Rai, for your insightful presentation. As a mathematics management, my concern is like AI being emitters, expanding scope is greenhouse gas emitters globally, and expanding, right? Being a resources manager, being a resources student, I would like to understand how can we work in that, because it has been it's our responsibility as a resources manager. We have to work in that also. So your perception, how can we work in that? Has there been any initiatives that addresses that it has been like emitter these days, and how can we address these things globally? Thank you.
Any other views, comments, questions? If not, so I would like to request to answer this one.
I'm sure that even in the examples, there's a lot of institutions, a lot of research, and even industry communities that are working at the intersection of forestry and AI. But I'm not aware about something like that, because I know that some people are working on agriculture, but I don't know about the forestry. And when I was for the talk, I think that I can find the person who's actually worked that intersection rather than me. And I was told that they were not able to do it. So I don't know, right? But I think you are, again, it could be regional, communities. I don't know what's happening in South Asia or Southeast Asia or around the world. So my simple answer is international. Yes, Nepal, I don't know. But if there is, I hope that the community will find each other. And the other question is the environmental sustainability, right? Because again, that's a huge concern. So there are two things going on. One is because right now those big LLM models, right, Gen AI techniques, they're very resource intensive. But a lot of companies are doing in a very careless way. They are not being trying to make it less resources. They are on a AI synchronous race. So where you are is you care about getting there faster, right? Getting there first, not trying to make more sustainable. So there's a lot of their approaches is not sustainable. A lot of this, and they are kind of like trying to scale these big models. But there's a lot of ways that you don't need all of these big models, right? You can solve the problems in a small model, and you can also do a lot of innovation on those small models. But then what happens? A lot of resources spent on becoming faster and bigger and getting there first. So there's a lot of platform accountability, that kind of push is there. Again, like I said, for a lot of students, you don't need very resource-intensive AI models. You can do with small, more less resource-consuming models. And even if you need like really high resource thing, rather than having different companies and compete. Again, this sounds very wishful thinking, but something like maybe UN or some kind of global, where instead of creating like 10 different companies making their own data center computing, if there is one common data center, I think that is going to be more energy efficient. But then there should be a lot of resource we put into other kind of. For me, particularly, I'm not a big fan. My research was more of the graphical causal modeling. I have never been a fan of these deep learning models, even though they are very powerful. So I hope that collectively we find more efficient AI techniques. Currently, AI techniques are very brute, almost like brute force, right? They are very powerful. They are very humongous and almost monstrous, I would say. So I really hope that I find that solution.
So actually we are at the end of this session. So there are not any questions comments from the floor, and let me conclude this. Let conclude this session. So distinguished participants, ladies and gentlemen, and our keynote speaker, Dr. Dovan Rai. So allow me to express my sincere thanks to our keynote speaker, Dr. Rai, for a very insightful presentation on the concept of AI and certification in forestry sector of Nepal. So I believe this presentation has enlightened us how we can use AI responsibly and effectively to improve the way we manage our forests. So the government of Nepal has given utmost priority to initiate digital governance. And the development partners like World Bank, Asian Development Bank, they have also provided support for initiating digital governance in Nepal. Accordingly, the government of Nepal recently changed the name of Information and Technology Department to the Office of Digital Governance. That is one example of how the government has given priority to introduce digital governance, and the forestry sector is not an exception. So we have been using AI in the forestry sector in different aspects. For example, forest inventory, use of satellite images and use of radar, and wildlife monitoring like smart patrolling, and also the government of Nepal is also initiating digitalization process or environment assessment approval process, and also the forest land providing to development projects. How we can use online approval process like that has been practiced in India. So that are the few examples that we have been initiating in the forestry sector of Nepal. So beyond that, how we can apply the available technology in the forestry sector. So that is another reserving areas that we have to explore. Although we have very limited time, like that Dr. Rai has given overall concept and application level to the background. But we need our time, maybe in detail, so that we can practically think of applying those technology in the forestry sector of Nepal. I think this session has given us areas that we can improve, basically in the academic and research institutions. So for example, the universities. Universities can develop course or subject focusing on application of AI in the forestry sector of Nepal. Although AI has made our life easy, but Professor Khanal has already asked, what is the ethical boundaries of using AI responsibility in the forestry sector and other areas? So it has, in another way, has killing innovation and creation among the faculties and students. So that is the critical part that we need to think on. Similarly, in the government sector, so I think it needs upfront investment and capacity strengthening. So government should allocate resources and capacity strengthening programs in the forestry sector, and also in relation to applying the AI technology responsibly. So we need kind of code of conduct in every organization, so that we can follow the responsible and effective use in the forestry sector. So with these words, once again, I thank our keynote speaker and organizers for providing me sessions here of this very important session, and also to our distinguished participants for their active participation. So with these words, I declare the conclusion of this session. So thank you.
Very successful presentation and for your guidance and facilitation. And I also want to thank Dovan Rai for your beautiful presentation. Now I would like to request Dr. Bahadur Karki, first campus chief of IIM Pokhara, former DPC Estimor, former advisor of Prime Minister, to please come forward and present the certification of appreciation to our keynote speaker, Dr. Dovan Rai, and our chair, Dr. Vishwanath Rai, sir.
Good morning, namaskar everyone. Really an honor. Thanks to the organizer for this opportunity. Although I'm sorry I missed your speech, but by the questions, hearing the questions, I'm sure it was very motivating, very inspiring, and very, I would say, intellectually challenging. So, congratulations, and always pleased to you.
Now, guys, we have completed the session. I would like to inform that there will be 4 parallel sessions in the respective hall. In this Awas hall,